All right, you guys. Welcome to pre-calculus. This is chapter 11. We're going to start talking about limits and intro to calculus. So 11.1a is an intro to limits. So a limit is a fundamental concept of calculus. You're going to be using this a whole lot, so you really need to understand it and know what it is. Limits are used in two basic problems in calculus: the tangent line problem, which we will talk about in 11.4, and the area problem, which we will talk about in 11.5. So an example of an area problem would be you're given 24 inches of wire and asked to form a rectangle whose area is as large as possible. What dimensions should the rectangle have? Okay, so here we know that the perimeter of this thing is going to equal 24, and we know that perimeter is 2 times width plus 2 times length. Okay? But we are looking for area, and we know the area is length times width. Okay, well, we can't solve things when we have two different variables. So we're going to get this in terms, we're going to get this area in terms of one variable. Okay, so here all I'm going to do is I'm going to solve for either W or L. So first I'm going to divide everything by 2, and I get 12 equals W plus L. And then let's go on ahead and we will solve for W, which means we will get W equals 12 minus L. Okay, so that's my formula there. So now here, I can go on ahead and plug that in. So that's L times my W, which is 12 minus L. Now, in order to solve this, I'm going to actually plug it into my calculator here. So I'm going to plug in X times, and then this is 12 minus X. And I'm going to graph this thing. Okay, so it's a parabola, which, if I were to multiply this out, I would get 12L minus L squared. Okay, so it would be a downward facing parabola. Okay, but I don't really want to graph this thing. I want to find the maximum of this thing. So, right, so way up here. And we could do that using, our parabola formula and negative b over 2a, finding the vertex of it, because that would give it to us. But I'm going to show you guys how to do this on your calculator. And you guys have already seen this, but we're going to go on ahead and we're going to go to our table, and we're just going to go in here and we're going to find where this thing hits a y value that's a maximum. And I have it kind of set at some lower values here. Let's see, let's start at, I don't know, let's start at a higher value here and then go in and look. Okay, so that's 35. Okay. And then we're going to cross here shortly, 5.5, 5.6, and you can see that these y values are still going up, and I'm scrolling through pretty fast. Okay, so I'm looking for where my y values start going down. Oh, look, they started going down. Okay, so at 6, right, so it shows that, 5.98, 5.99, that all of these are 36, but really it's going to be 6, right, because 6 times 6 is 36. Okay, so that is going to be our length. Okay, so 6 is going to be our length, and if we plug length back in for this width, 12 minus 6, our width is going to equal 6 also. So that's going to be the area that gives us the biggest, dimensions that give us the biggest area. Okay, so limits are finding what gives us the biggest, okay, or what does it get closer and closer and closer to. Okay, so let's take a look at this actual definition of a limit. So if f of x, so the function, the y value, becomes arbitrarily close to a unique number L as x approaches c from either side, the left or right, the limit of f of x as x approaches c is L. This is written as limit, and this says x approaches c, just in case you can't see that little stuff right there, of some function equals L. So all we're saying is as x gets close to a number, what's the y value? That's it. That's all we want to know. So we're saying as x approaches some value, the y value is another value, and we're calling that L the limit. So let's go on ahead and take a look at this example here. So it says, use a table to approximate the numerical limit. So limit as 3x minus 2 as x approaches 2. So that's what we want to get closer and closer and closer to. So I'm going to go on ahead and go into my calculator again, even though we've already got a graph on here for you. I'm going to show you guys how to input it. So we're inputting it just like normal, 3x minus 2. Okay, if we graph this thing, we can see it's a linear equation. Okay, but now we want to go to our table, and I'm going to go, so I'm not going to start at 6. We want to get close to 2. So I'm going to start at, like, I don't know, 1.9. Okay, and I'm going to set it, and that's why I had my calculator set in such small increments. Here we went in 0.001 increments. I'm going to go in 0.01 increments. Okay, you want to get kind of close, but you can see at 1.9, I'm at 3.7. We want to see as we get to 2, what are we getting closer and closer to? Well, if we look at it coming from this side, we're getting really close to 4. And if we look at it from the right side, we're getting really close to 4. So our answer then is going to be 4. So the limit of some function as x gets really close to 2 is 4. That's our answer. Okay, so we're seeing what number are we getting close to. All right, let's take a look at a couple more of these. So it says use a table to estimate the limit numerically. All I'm going to do is plug this into my calculator. Okay, so I'm going to go to y equals. Okay, and so this is going to be x divided by, okay, a whole bunch of stuff here. The square root of x plus 1. And then minus 1 and close those parentheses. I'm going to graph this thing just to see what it looks like. Okay, so that's what it looks like. And now I want to know as x gets really close to 0, okay, what are we approaching here? Okay, and here on the graph, you know, it looks kind of like it's approaching 2, but we're going to go into our table and see. So I'm going to start at, we'll just start at negative, let's see, negative point, I don't know, point 2. And we're not going to start too far back, but I am going to go on ahead and change this to 0.005. Okay, so we're going in really small increments. All right, so now we're at negative 0.2. Okay, we're getting closer and closer and closer to 0. I'm just scrolling so that I can get really close to 0. Okay, so you notice at 0, it gives me an error. Okay, so it doesn't actually touch 0. Okay, that would not work, right? Because a denominator can't be 0. Okay, and that's what we would get if we did this. So here, because we get the square root of 1, which is 1, minus 1 is 0. Okay, all right, so error at 0, but if we look coming from the left side, we're getting really close to, well, here it's 1.9975, and coming from the right side, it's 2.0025. So what do you think this would be really, really close to? Well, it's somewhere around 2, right? So our answer here is going to be 2. And a lot of times you'll see that. There will be an error at the actual spot that we're looking for, but we want to know what's it getting really, really close to. So coming from this side and from this side, it's getting really close to 2. So our answer here is 2. Now let's take a look at this next one here. So this one is going to be x to the third minus x squared plus x minus 1. I probably need parentheses around all of that. Oops, not brackets, parentheses. So I'm going to go back to the beginning and I'm going to insert. So second insert, and I'm going to insert a parenthesis there. Okay, and then I'm just going to do divided by parentheses x minus 1, okay, because I want to divide by that whole thing. All right, so let's take a look at what this graph looks like. Okay, so it looks kind of like a parabola, but since it's an x to the third, there's probably a little doo-wop in there. Okay, and we're looking for the limit as x approaches 1. Okay, so let's go on ahead and let's go into our table. We don't want to be so close to 0 anymore. Now we want to be close to 1. So I'm going to start at, I don't know, 0.85, okay, or maybe 0.09, okay, something like that. And I can, you know, play with this back and forth. Okay. So here I want to get really close to 1. I probably should have started at like 0.9. So yeah, let's do that. All right, that way we don't have to scroll through everything. And then go to our table. Okay, so 0.9. We're still going to have to scroll a little bit. Okay, so as we get really close to 1, you can see that 1 is an actual error. But as we get close to it on this side, it looks like it's getting really close to 2. And as we get closer to it on this side, you see it's decreasing and getting really close to 2. So our limit on this one is 2 also. Okay, well, here's another one. So lots of examples, I know, but examples are good. You guys like those, I hope. All right, so find the limit of f of x as x approaches 3, where, all right, well, now we have a piecewise function, okay? So it says f of x approaches, where it approaches 3. Okay, so we need to go on ahead and we need to graph this thing. So when x is not 3, our y value is 2. Okay, so our y value here, okay, is 2 as x approaches 3. Okay, so this way and this way, but there's a hole right there. And then x is 0. Okay. Our y is 0 at x equals 3. Okay, so remember, these are our y values. These are our x values, are our domain. And we want the limit as x approaches 3 for f of x equals 2 in this case. Okay, because we don't want to know, we don't need that. We don't want to know what this thing is doing at 3. We want to know what it's doing as it gets close to 3. So as it gets close to 3, our limit is actually 2. Okay, because once again, we don't want to know what is it doing at that number. We want to know what it's doing as it gets closer and closer and closer to that number. So this one, as it gets really close to 3, it's at 2. And this one, as it gets really close to 3, it's at 2. Okay, so once again, we want to know what's it doing as it gets close to it, not at it. Okay, so this one would actually be 2 and not 0. Okay. Let's take a look at a couple others. All right, so this next one here, these are limits that fail to exist. Okay, so we're going to look at these. So this one right here, if you graph this on your calculator, you get something that looks like this. So this side approaches from there, and this side approaches from there. Well, this one does not exist. Okay, and the reason is it does not approach the same number from both sides. Okay, it has to approach the same number from both sides. Okay, otherwise it DNE does not exist. Let's take a look at this next one. Okay, so this next one here, it also does not exist. Okay, and the reason this one does not exist is because it increases or decreases without bound. So in other words, it's hit an asymptote and it is just going to infinity. Okay, and if you look at the numbers here, you can see that it's just going to keep going to infinity as you get closer and closer to 0. Okay, so right here, that means, oh, that's getting exponentially high. Okay, so this one does not exist, so we put DNE. Okay, and the reason is it increases, or in some cases it would decrease. Okay, this one actually increases without bound. Okay, meaning it goes to infinity. So negative infinity or positive infinity. Okay, or, okay, that's not to or from. Okay, and then this last one here also does not exist. And our reason that this one does not exist, if you can see right here, it goes do, 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 do. Okay, and if you can look on this graph here, you can see that it bounces back and forth. Okay, so these values are exactly the same. Okay, so this one does not exist because it oscillates, right? Goes back and forth between two values. Mm. All right, so you guys have a quiz or a little, assignment. Make sure that you do that and ask for help if you need some help. And I'll see you guys next time.